So in this last step of the experiment, we need to measure the in other words, we are going to confirm Ohm's law using a fixed resistor, and uh, by varying the voltage, we are going to then calculate the current at each step. And using this, we are going to attempt to verify Ohm's law, because Ohm's law says that voltage is proportional to current for a fixed resistor. In other words, Ohm's law says that V is equal to I times R for a fixed resistor. So we're going to be using a fixed resistor, which is 470 ohms, and we are going to increase the voltage and we're going to calculate the current. We would like to measure the current, but this time we're going to calculate it. All right. So um, so this is the circuit we are going to use using Arduino microcontroller to get variable voltages. So this microcontroller has been programmed. It's been programmed to give a PWM output, and with the PWM output, the duty cycle of the output, a square wave, is varied so that the average voltage changes. So when the duty cycle is close to 100%, the average voltage is close to 5 volts. And when the duty cycle is reduced, we'll see that the average voltage is lowered. And the meter is going to measure the average voltage for us. So the first step would be to construct this circuit. So as you can see, we have a power supply here, and we have a resistor. So the power supply is connected directly to the resistor, and we have the voltmeter, which is going to measure the voltage across the resistor here. And if you look in this circuit diagram, you'll see it's similar as well. So we have the resistor here, and we have the power supply across the resistor, and we see that one of the pins of the resistor is connected to the negative of the battery, which is ground, and the other one is connected to the positive. But for the positive pin, we are using pin number 3. So we can go ahead and connect that. So first thing I'm going to do is to put the resistor in the board that we're going to be using. So this is the resistor right here. So place it in the board here. And then I want to connect the voltmeter across it. So again, I'm going to set my meter to volts. Okay, I'm going to put the positive on this side and the negative on that side. Alright, so the negative, I'm going to connect it to ground. So I'm going to go ahead and connect it to ground. Okay, let me move this board somewhat. Just to stabilize it. Okay, so I want to connect the negative to ground, and I'm going to use this blue line for ground. This blue line says that all of these holes are connected. So if I connect ground from the Arduino to this one, all of these will be connected to ground. So let me go ahead and do that. So this ground here, which is after pin 13, I'm going to put this red wire into ground, making all of this ground. Instead of using the red wire, I'm going to use the orange wire, and you will see why. Okay, so now we have ground on all of these areas here. So I said I'm going to connect the resistor to ground. So since I put the meter, the negative lead of the meter here, I want to connect this one to ground according to the schematic. So I'm going to take this one and connect it to ground. So to connect to the resistor, I need to go in the same row as the resistor. And so from the same row, I then connect directly to the same slot with the blue. So now this one is connected to that one. Alright? Okay. Okay, next I need to connect the top of the resistor to pin number 3, which we are using for our input today. Pin number 3. So I come here, and again to connect to the resistor, I need to connect in the same row as the resistor. And I go to pin number 3. So 0, 1, 2, 3. Alright. pin number 3. Then I need to provide 5 volts to this the other rail here. So I'm going to take 5 volts from the Arduino, go in the 5 volt slot here, and send 5 volts to the rail. And we're going to do this because we need to use 5 volts and ground to select the voltage that we want on the output. Okay, so this takes us now to our table here. So to select the output voltage, because if you look at this table here, based on this experiment, we need to we are expected to send 0 volts to the resistor, then 1 volt, then 2 volts, then 3 volts, then 4 volts, then 5. So essentially what we are doing is that we are going to select the output voltage that we're going to get from pin number 3. And to do this, we need to use this table. Okay, with this table we're using pin 8, 9, and 10 as control pins. So for 0 volts, we need to connect pin 8, 9, and 10 to ground or to 0 volts. So let me connect pin 8, 9, and 10. So we have pin 8 to ground, also pin 9 to ground, and pin 10 to ground. Okay, so all of these are ground now, and now we can measure the voltage across the resistor. So it's approximately 0 volts. So again, according to the table, when we want 0 volts, and of course we are going to put the measured voltage right here. So when we want 0 volts, pin 8, 9, and 10 should be all 0 volts. So right now, pin 8, 9, and 10 are connected to the blue slot, which is the ground. So we'll write 0 here. This is the result. Then to select 1 volt, we need, so we have 0 volts here, and of course if we have 0 volts, the current will also be 0. To select 1 volt, we need to make pin 8 high. So we have a 1 here, and a 1 represents 5 volts. So to select 1 volt, we need to do this here. So, and then we're going to, any voltage we measure, we're going to write it right there. So I take pin 8, and I move it into the positive slot. Okay. Okay, pin 8 now is in the positive slot. Okay. Let's make sure everything is connected properly. Okay, I'll take a break.